continue. When we discuss on the fall, normally we will discuss about the competent strata. Okay, what means the competent strata? When we are folding, involve brittle deformation, brittles. So then we are the structure we call that competent rock. What's mean the competent rock? The fold strata behave as a brittle material. Mean the layer are folded are retaining their original structure. Means retain the original structure. Means here when we are folding in this layer, so this thickness of this layer on this side and this side is similar. It's not that retain the original thickness. But if we have another term we call it incompetent strata. For incompetent strata is discussing about the fold that involve ductile deformation. What's meant by ductile deformations? We have incompetent rock which is folds, but their thickness of the layer is changed rapidly. For example, this is the folding. Okay, so you can see this is quite thick layer on this side, but is changed to quite thin layer here. So the size of the thickness is changing because of that deformations. Okay, so we call that is incompetent structure. So you see here this layer and this layer, so change in thickness. So you can see here change the thickness to from thick to a bit comparatively thin from here. Okay, so this is called the incompetent strata. Also another term in discontinuity structure, we also discuss talking about unconformity. Unconformity is a layer, is a boundary between two formations at different edge. Because see, this is we have the layer, the structure of this rock, this sedimentary rock. This quite deep the angle. So compared to this layer, this sedimentary rock is horizontal layer in horizontal form. So meaning that we have a sequence of deformation in each. So this rock is deposits earlier than this one. So this is oldest rock, this younger rock, and this rock, older rock is experienced tectonic. Then this rock will bend or incline in this direction. But for this rock, this younger rock, is not experienced tectonic force, so it's keep their position in the horizontal form. So now we are talking about geological structure. So how we measure the geological structure? Normally we use compass. Then we measure strike, deep direction, and deep angle. As we discussed in lab number 2, we have to find this data. But in our lab 2, we are find this deep direction, deep and deep angle using map, not based on the outcrop exposure. But for this, we obtain this information of the based on the visual, based on observation on the field, which is we using compass, and we are measure the direction, the angle. Yeah. And this, for example, this is the strike. Like say this is a rock exposure. This is bedding plane. So you can see this is the deep direction. We put our compass. This is deep angle of this plane, and then we have strike. Okay. Okay. So the application, why you have to study this geological structure. So the important of study of this also is that you are we'll know in our rock mass we have internal weakness. So look at internal weakness, our subsurface is have weaknesses that will affect the stability of the engineered structure, or can affect the groundwater flow, and also affect, if we have groundwater effect, the groundwater flow means affect our structure like dam or our aquifer. Okay, this is photos like before. We have this outcrops, this model. So if we will not understand the geostructure, then we cannot imagine how our subsurface look like. So that's why you have studied on the rocks, we have studied on the weathering, we have studied on geological structure. Based on that information, you are able to model our rocks underneath. So to understand that weathering is, we discuss, we have before we find rock, we have a layer of soil because of weathering. And then in terms of weathering, we have a few grades, which are the fresh rock is which the rock is unweathered, untouched by the any agent of weathering. So when you understand the rocks, type of rock, you understand the weathering profile, then you understand on the geological structure, then you are able to understand the rocks. For example, you will understand the rocks subsurface model. For example, this is, let's see, you just imagine this cut is not happened yet. You are on the top of this hill. You want to investigate this profile. You investigate this profile, whether you are want to, before you can able to design this soil, this slope, you have to find the profile. So to find this profile, soil profile, so this is rocks in granite. So you can imagine this is granite rocks. So means in terms of the weathering, we have layers of grade of weathering. So in terms of the weathering, understand that the criteria of this profile. So when we are reached near to this rock, so this rock, when we are find rocks, so you understand the structure of this rock. So that you can find this rock granite, you are able to find joint. You can see this is joint, fractured called joint, or you can find fault. So mean that here you are able to see underneath before you cut the slope. Similar to like this is also granitic rocks. So we are able to understand the profile layer here. So this is a rock called rock head. This is a transition between rock and soil. So when you find rock, you are able to understand this is granite. You are should able to find rock joint have system. The only thing if you don't know is the spacing. But if you are doing this borehole, if you have do borehole, you can say you are on the top this, before this rock, this slope is cut, you are doing borehole, you drill here, so you can reach the top of this top of the, we call it rock head. Then you do boring, coring. Then from the coring you are find the fractured system. So you are able to find the rock quality designation. We will discuss this in chapter number, after this chapter number 6 or 7 on the rocks rock testing. Okay. No. After this, about on SI, site investigation. So we discuss on the how we want to know the quality of this rock, how fracture of this rock. So we are measure the the quality rock quality designation based on the fracture system here. So if you know on granite, you know the model of the granite. But when you're looking on the metamorphic rocks like phyllite, you are this is rock phyllite looks like, so you know that. So this is a example of the phyllite failure in phyllite area. See, so let's here for example like this. And this is the phyllite rock. So this is failure. So you know this is a our top model should like that. This is soil covered. Then now we are second slope. You can see the structures of the foliation. Yeah, is it a very close spacing of foliation. So that's why you can see here very fractured material failure here because of this model. See, which side you can see the clients with side. So now you are able to see this the subsurface. We have this layer of very deep material, and then you can see these rocks. Okay, this metamorphics. So in sedimentary rock, it's look like this. So for example, you are here, we want to do this model in this slope. Before the slope cut, you can, if you do borehole, you can understand how this rock looks like. So you can see this here. You can see structure of sediment, but here you cannot see anything. Okay, this is called unconformity. We have two different type of rocks. Yeah, not two type. Two structures of rock. Yeah, quite. They have inclined bedding here, but here is quite gentle. Slope, the deep angle. Similar like this, you see here on the top of this one, you can see you cannot see any structure. But if you go deeper, you can start see the structure of geology. You can see the bedding here. Start see bedding. Then go deeper, you can see the bedding. Then we go deeper, and then you can see the structure of this. This called syncline. When you are here, before you reach it, you can see this bedding dipping like this, and then this dipping like this. So now we go down, you can see this how it look like. We have dipping like this and then dipping like this. So how the model you want to model the underground, similar like this. You can see here this is the bedding plane. So you can model this subdivision rock. Then okay, when you know this fracture system rock, so then you are able to do this slope stability as we are doing in the lab number 4. So we have to investigate the bedding, how is the fracture system or this bedding plane system. So this quite steep incline, but here quite gentle incline. See? So this one quite stable, but here see. So you have studied the system, then you can tell the stability of this slope. Okay. Also here is another shows your alignment of road from the Porcelain in Sipam Porcelain to Kamporaja, Cameron Highland. So you can see this is how the alignment of road looks like. So this follow the topography, how the design, the alignment is they don't want they want to make this gradient quite gentle because we have steep terrain. Just imagine this is 1000 meter, here around 400 meters. So to increase to 400 to 600, we have 600 meter high. So that's why they do like this. So you cannot go straight here or like this because of the terrain. Okay, for the trails, or like this, or like this, more shorter. So because of the terrain, so we have terrain, and also because of the elevation. Let's say 400 meter here is 1000 meter here, so we have not enough distance to get the gradient, smooth gradient. So because of that gradient, so it will cause a lot of issue of stability. Okay, also stability. So we have to find the geological structure of the area, and then then you're able to design this. So this example for Kampung Raja post limit. So in tunnel, also important to study the structure of geology. See the joint here. You can see the joint here. Okay. Then you can see the water here, a lot of water flowing. So when you study this joint, then you are able to design the stability of this tunnel. Okay. Also in yeah, this example tunnel in Pahang Selangor raw water transfer project. They have a quite long tunnel. They built a long tunnel. So yeah, this is then the drill structure also important in Chopra, in Hong Kong, in Langkawi. They use this structure of geology to as a tourist attraction. So for example, here this is a column of volcanic rock. This is in the China, Jiangxi Danjia National Park. It's a rainbow mountain. See the bedding, the sedimentary rock. They have different color because of the mineral of this rock. And so in China, so you can see this beautiful crop, because you can see the fault line, yeah, system of fault. Okay, then and that's all. Thank you very much for your attention.